Okay, so are you ready for this? Scientists are like, they're figuring out how to twist atoms. They can actually create materials with properties we've never even seen
That's
before.
like bending the laws of physics.
Yeah, exactly.
Nice.
We're diving into the dual twist project today,
Yeah.
and their research is like absolutely fascinating. So today's source, it's a scientific article about this project. It's funded by the European Research Council, and it's led by physicist Christian Schneider at the University of Oldenburg. So we're going to break down exactly what makes this research so special, and trust me, it has huge implications for the future of like all sorts of tech. So first,
That's right.
let's talk about 2D materials. These are incredibly thin sheets, just a few atoms thick, and they act completely different compared to bulk materials.
Yeah, it's all about the quantum world.
Yeah.
You get down to like that atomic level, materials start exhibiting
Ugh.
these bizarre quantum phenomena
Yeah.
that we just don't see in everyday objects.
Right.
So in 2D materials, the electrons are basically trapped
Mm-hmm.
in a flat plane. And that leads to all sorts of interesting behaviors.
So it's like they can't move in 3D space.
Exactly.
It's just 2D. So it changes how they can interact.
Completely.
And Schneider's team, they've already used these 2D materials to build working lasers. Back in 2021, they managed to make these 2D materials emit laser light, even at room temperature.
Yeah, that's a huge step towards creating powerful and versatile nanolasers that could be used in everything from like telecommunications to medical devices.
That's so cool. Okay, so we've got these 2D materials, and they're already like pretty amazing on their own. But the Dual Twist project takes things even further. They're working with what are called bilayers, which are essentially stacks of two 2D materials.
And here's where things get really interesting. By simply rotating these layers, we're talking tiny atomic level rotations, you can drastically alter the properties of the entire material.
Well, hold on. You're saying just by twisting these layers, you can change how the material behaves? That sounds like something out of a science fiction movie.
It is. It's called Twistronics, and it's revolutionizing material science. It all comes down to the way electrons interact between the layers. When you change the twist angle, you're essentially rewriting the rules of those interactions, leading to all sorts of unpredictable and potentially groundbreaking results.
So can you give me an example? What kind of changes are we talking about?
Sure. Let's take graphene, for example. It's a single layer of carbon atoms arranged in a honeycomb pattern, and it's a fantastic conductor of electricity. But twist 2 layers of graphene just slightly, and you can turn it into an insulator, blocking the flow of electricity, twist it a bit more, and it could even become a superconductor.
That's incredible. It's like magic, but at the atomic level. So how do they even study these twisted bilayers? It sounds incredibly complex.
It's a huge challenge. They're using a specialized setup called the light cage, which is basically a microcavity that traps light particles. And by observing how the light interacts with the twisted bilayer, they can gather data about its properties.
So they're using light to probe the mysteries of these materials.
Exactly. But even with this advanced setup, predicting the behavior of these twisted materials is extremely difficult. Even our most sophisticated computer models struggle to keep up.
So how do you study something that's so unpredictable?
That's where Schneider's team is taking a truly innovative approach. They're using a quantum simulator.
A simulator. So are we talking about a computer program?
It's more than just a computer program. They're using photons, which are particles of light, to simulate the behavior of electrons in the twisted bilayers.
I'm trying to wrap my head around this. So light is acting as a stand-in for matter.
Yeah, it turns out that the equations governing the behavior of light and matter in these specific systems are surprisingly similar. So by studying how the photons interact in the simulator, they can get a glimpse into the quantum world of those twisted bilayers. It's a brilliant workaround for the limitations of traditional experiments.
That's so cool. This is amazing. It sounds like they're opening up a whole new way of controlling matter.
Exactly. The ultimate goal is to understand and manipulate these twisted bilayers to a point where we can actually control previously inaccessible quantum states. Think about the possibilities for quantum computing, secure communications, ultra-sensitive sensors. The list goes on.
This is mind-blowing stuff. We started with a single scientific article about twisting atoms, and now we're talking about a potential revolution in technology.
And we're just getting started, so stay tuned for part 2.
We'll be back. So welcome back. Last time we were talking about how scientists are learning to twist atoms to create these materials with mind-boggling properties. It's so cool.
Yeah, it's really exciting stuff. You think about the possibilities for incredibly precise medical sensors, like devices that could detect diseases at the molecular level, even before any symptoms appear.
Yeah, that's what I call preventative medicine. And we were just discussing Schneider's team's success with creating 2D lasers. So what could those lead to?
Well, imagine ultra-fast, energy-efficient communication networks that use light instead of electricity to send information. Or think about how these lasers could revolutionize computing, leading to entirely new types of devices that utilize the power of quantum mechanics.
Yeah, okay, I'm starting to see how this could be like a total game changer. But let's talk about the how for a second.
Yeah.
How do researchers actually manipulate these materials? Is it like building with microscopic tweezers?
It's more like
Yeah.
fine-tuning an orchestra, where each instrument is an atom, and the music they create is the material's properties. So researchers can apply electric fields, they can adjust the temperature, and of course utilize the twisting technique that we talked about earlier. So by carefully manipulating these parameters, they can essentially tune the material to behave in specific ways.
That's a great analogy. So it's less about physically manipulating individual atoms and more about creating the right conditions for them to interact in ways that give us the properties we want.
Exactly. It's all about controlling those interactions. That's where the magic happens.
Yeah. So they're conducting this atomic orchestra, using light to probe these materials and quantum simulators to predict their behavior. It's incredible to think about how far we've come in understanding and manipulating the building blocks of matter.
Yeah, we've come a long way.
Okay.
But there's still a long road ahead. One of the biggest challenges is figuring out how to scale up production of these materials. Right now, they're working with tiny samples, often just a few micrometers across, to create practical devices. We need to figure out how to manufacture them on a much larger scale and with consistent quality.
Right, because it's one thing to create a tiny sample in a lab, but it's totally different to mass produce it for use in like everyday technology.
For sure. And then there's the cost factor. Some of these materials are incredibly expensive to produce, which could make them impractical for widespread use. So overcoming these hurdles will require a lot of ingenuity and collaboration between physicists,
Like chemists,
material scientists, and engineers.
It sounds like a monumental task. It's fascinating how this all started with a single scientific article. And now we're talking about potentially revolutionizing entire industries.
Yeah, that's the beauty of science. It's a constant journey of discovery, pushing the boundaries of what's possible.
And this dual twist project seems to be right at the forefront of that journey.
Absolutely. The possibilities are truly mind-boggling. And in the final part of our deep dive, we'll explore some of those possibilities in more detail, painting a picture of what the future might hold.
All right, so welcome back to our deep dive into the dual twist project. I mean, we've been talking about some really cool science, but we've honestly only just scratched the surface of what all of this research could mean for the future.
It's true. It's all about like the potential. We've talked about faster communication networks and incredible medical devices, but that's just the tip of the iceberg.
Yeah.
So imagine like ultra-efficient solar panels that could capture nearly all of the sun's energy, or materials that can like repair themselves at the molecular level, like something out of a sci-fi movie.
Oh, wow. Self-healing materials? That would be a game changer, especially for like things like infrastructure or even like spacecraft. So what else? What else could we see?
I mean, the potential applications, they span almost every field you can imagine. Think about advancements in areas like robotics and artificial intelligence, all powered by lightning-fast quantum computers built with these new materials. We could even see breakthroughs in energy storage, leading to batteries that last for weeks or even months on a single charge.
It's hard to even grasp like the scale of the potential impact. But, you know, with all this talk about revolutionizing industries and changing the world, it's important to remember that we're still in the early stages of research.
Oh, yeah, for sure. There's still a lot of work to be done before these technologies become part of our everyday lives.
Yeah.
Like scaling up production, finding ways to make these materials more affordable, and ensuring that they can be integrated safely and effectively into existing systems. Those are just a few of the hurdles that we need to overcome.
It's a massive undertaking, but the potential rewards are so significant, it makes you wonder what other seemingly impossible things might become possible in the future as we continue to explore and manipulate the quantum world.
And that's the beauty of scientific discovery. It constantly pushes us to rethink what we thought we knew and opens up entirely new possibilities. It's a journey that requires patience, ingenuity,
and a healthy dose of curiosity.
Well, our deep dive into the Dual Twist project has definitely left me feeling inspired. I can't wait to see what breakthroughs emerge from this research in the years to come.
It's a field that's ripe for innovation.
Yeah.
And I have no doubt that we'll be seeing incredible advancements in the not-so-distant future.
Yeah, and to our listeners, we'll leave you with this. The future of technology is being shaped right now in labs around the world, so keep exploring, stay curious, and who knows, maybe you'll be the one to make the next groundbreaking discovery.